Welcome to Minding My Business. I'm Danielle Sabrina, and I have a very exciting guest, the inventor of an incredible semiconductor technology that is actually going to help the United States be protected from missile attacks. Welcome, Mike Kappes from Next Semiconductor Technologies. I'm really excited to talk to you today because what is going on in space right now is fascinating. And you had made a comment earlier that I thought was interesting. And I wanted to talk to you a little bit about, I want to talk about what the space economy is right now and what does everyone need to understand in order to be able to contextualize the rest of this conversation. So tell me about what's happening right now in the space economy and who the players are.
Yeah, well, thanks. Nice to be here. I think what we can look at in the space economy is everything's shifted. There was a small company called SpaceX that sort of changed the game a while back, maybe, in about 8 years, 10 years now. And what they did was they had the idea of democratizing space. Let's say it wasn't their idea, but it's kind of happened. They brought down the cost of launch. So by building better rockets, reusable rockets, building larger rockets that can take larger payloads, they reduce the cost to put mass weight into space. And with that reduction in cost, they've been able to launch additionally their own Starlink network. But that cost reduction is driving this expansion of, it's becoming more affordable for companies and countries to access space as both a SATCOM network. You've got ideas around global imaging, information. We use, of course, for weather tracking, things of that nature. So there is a movement from space as a government-only access to commercial access. And I think the game is on for accessing what you can do in space.
Well, now that the game is on, what are the risks involved with now that this is starting to be democratized and opening up in a commercial level?
Yeah.
Like, what are our vulnerabilities
you can imagine,
right now?
let's take one approach where maybe there was an idea where everyone can afford to go to space. We put too much equipment up there. No one's regulating it. Everyone's able to look at everybody's backyard. There's surveillance, security, privacy. So that hasn't happened. It's been more or less one major network provider, SpaceX. Amazon's coming in quickly, but I think the game is still more or less managed and regulated by governments. And so the U.S. government got to space early. We're obviously leveraging SpaceX for quite a bit of that access, but we've taken the high ground, I think, in global surveillance. We've gotten the high ground for what we see is a push from defense to create better battleground communications, better battleground surveillance, better monitoring. There's just a tremendous amount of assets we now have in space that are defense focused that I think will only increase.
How does this tie into the Golden Dome project that is with the government, the U.S. government, right?
Yeah, so you could argue the Golden Dome has been brewing for quite a while. There's a program called Starshield that was a derivative of Starlink, and Starshield was reference to Star Wars from the 80s. It's an idea that with a network of low Earth orbit satellites, you can do a tremendous reconnaissance and surveillance capability that you have. You can also offer communication networks that could be over adversarial ground, right? So instead of handheld radios, we can start looking at space as being a point where we can pull information from faraway territories into generals that are making decisions in enclosed rooms in DC, let's say.
Where does a semiconductor chip come into this? And what is a semiconductor chip?
Yeah, so semiconductors are actually the foundational signal processing elements of everything we do in our digital economy, digital world. I mentioned that I look at the top 5 companies in the world by market cap, and they're all founded on some form of semiconductor component development.
For someone who has no idea what that is, like
Yeah.
obviously you say chip and a chip comes
Yeah.
into mind, but what could you paint a visual
Yeah.
for me? Because these chips can be, from what I understand, like the size of a $50
Yeah.
and house enough, like how much information could a chip that size?
Yeah, it's crazy. I think you look at the Library of Congress and you say, we can condense that into memories, a few memory chips, or if not just one. So I think when you look at it, what we're doing is to create a manufacturing technology, and this is primarily led by a company in Taiwan called TSMC. But that manufacturing technology has allowed us year over year, what's called Moore's Law, to basically progress the ability of chips to get more capable, lower power, and lower cost at the same time. And there's no other business that we can get better, lower power, basically better and lower cost year over year. And that move has pushed all our information technologies gone through chips. So chips are designing circuits and processing elements at another level where you manufacture these things through an offshore. There's only one fab in the world that makes the most advanced chips, for instance. The cost and scale of this chip industry is, I think, to most people will be just fantastical. I mean, you can look at Apple. I mean, they don't have a chip business. They don't have a phone, right? Qualcomm, Broadcom, all these chip industries have fueled basically every living convenience we have almost. I mean, outside of biotech.
Okay. And
Yeah.
then so say you have a chip going up in space. What physical size is that?
So the chips themselves will be small. Typically, chips will be less than centimeter by centimeter, something of that nature.
Oh, that's small.
Yeah, yeah. And the really, really large chips, which are kind of rare, are generally general purpose devices that are kind of meant to solve a lot of different problems with versatility. But when you look at making things for space, you look at customizing solutions. Customizing means condensing general purpose logic and general purpose functionality into something that is more, well, certainly more focused on the mission you have in the application you have. But the idea that by customizing that circuitry, you can make it lower power and lower cost and so on over the general purpose device. That's kind of the idea of custom chips.
Now, I've heard that your technology is been referred to as the Pentagon's secret weapon.
Yeah.
Why would people be saying that?
It's technically not a weapon, but I think the idea that the chips are information, right? And so when you look at where we make battleground or defense or everything's information in a sense, right? So we can access information quicker through chip technologies. And if you look at the progression of where we've gone from pagers to cell phones on our Dick Tracy, if anyone remembers that guy. On their wrists, right? And so I think the idea that the Pentagon is leveraging chip technology to advance its interests, of course, it's been that way. They track commercial interests, and commercial interests have driven some of the defense interests to kind of catch up a bit, and kind of.
What defense interests do they have right now?
Yeah, so what we're just kind of excited about is that the Defense Department of War, is very keen on gaining the high ground in space and winning, I think, an advanced war on information management at a global level. So when you look at the low Earth orbit satellite constellations that are supplied by Starlink and potentially Kuiper and some other networks that are going to come up, as a rule, those satellites go everywhere. They traverse the Earth. They are interlocked or interlinked, and they go over sovereign territory and enemy territory. They go wherever they want to go. No one can stop them. They're bulleting through space at incredible speeds, and they go over the horizon typically in about 4 to 5 minutes. So,
oh wow.
So they are scanning overhead. They have the ability to speak to cell towers, speak to cell phones. They have the ability to take imaging. They have they offer a global network and a global surveillance network that if you're an adversary, that's the last thing you want is someone watching what you do constantly.
So our like with going back to the Golden Dome project, that initiative is really about like getting all of this to space first, so that we're the leaders in it and that we have an
Yeah.
upper hand. Because what I'm hearing you say is like,
Yeah, it's not a shared environment. I mean,
yeah,
it will be a contested environment. We have what's called the Space Force for a reason. It wasn't, it wasn't a
right.
joke. It was it's a real defense interest. And yeah, I mean, I think the agenda I kind of recognized was that it's not kumbaya. It's not let everyone let's welcome space together. It's we need to get there first, which we have, and we need to protect our dominion there. That we protect the high ground, and that's
Because if
it.
we're not, then that's when like missiles could attack us and think. Because
It gives us a what we call asymmetric advantage,
okay,
having the ability to detect and survey adversarial launches, adversarial missile launches, and everything that we gathering of troops, movement of goods. So we don't really necessarily want to give that capability away to adversaries. It's something that we would like to manage and control ourselves.
and your semiconductor technology is
Yeah,
the only one, right, that has jamming capabilities,
anti-jamming. So
anti-jamming.
what we're trying to see, what we kind of saw with the first generation of Starlink and the global networks is that no one obviously it was a very useful tool in Ukraine. We applied or Musk applied some assets to the Ukraine conflict, and there was kind of the first attempts at Russian jamming of these Starlink satellites.
Can you explain what jamming is?
Jamming is when you do not want a satellite to function over your sovereign territory, and you have the ability. It's an international law. I think that they're not allowed to use bands of you own the bands around bands being frequency spectrum around your territory. And so what jamming is you basically want to white out the communication link. So a satellite's going overhead, you want to jam it by inserting energy in the bands it's trying to communicate with to ground or observe, and you want to kind of light it up with so much energy that it overloads its system. And so jamming would make the satellites more or less just dumb objects running across the sky.
I don't
Uh,
know why I have visions of Star Wars flashing through
it,
my
it it
mind, but
feels
is
like
this
that, right?
like
Yeah,
because I'm how is space? It's not like it's regulated. It's not like, oh, this is
it's
like the
not.
United States' area
Yeah,
right here,
yeah,
or
yeah,
like this is
yeah,
Russia right here. So
yeah.
could we be entering in the future something that feels very Star Wars?
Yeah, I mean, there's certainly experts that could talk to that better, but I think the idea that I see is that we are there first. Starlink and SpaceX in particular have given us advantage on launch. So you can imagine we're on ground. We're in the real estate and space early, and so now we're sort of creating our dominion. And I would argue that we're going to be the most aggressive at innovating in space, and that gives us, perennial advantage.
What is that going to look like? Like what I'm visualizing like Earth,
Yeah. Well, it's actually really far away, and there's a lot of space out there. And I think the
right?
best way to think about it is like the Russian dolls, or concentric circles, right? So satellites are not necessarily that big. Maybe a largest ones can be a trailer type of size. So when you put that in space, even on the ground, it's not relative to the Earth, it's not great. So 1,000, 10,000 of these things is not something that is polluting the sky or creating a lot of anomalies. There's actually a lot of room up there. It's dense, in terms of if you look at a satellite map. But you look at a satellite map, but you're seeing an entire half of the globe, right? So it's it's kind of misleading visually.
Right.
There's a lot of space out there, so it's there's plenty of room for us, commercial interests, adversarial interests, to be in space today. And so having an advantage that we see on creating the most advanced equipment and capabilities in space, I think gives us one ability to stay one step ahead of whatever adversarial capabilities there are.
So is like SpaceX and Blue Origin, which is Amazon's company, are they building their own chips?
Yeah. So both SpaceX and Amazon are at their core of their space program have a semiconductor development capability that they absolutely build their own chips that allows them to make better equipment, more lower power, lower cost. I would say that they're driven a bit by economics of their solution to also do chips, because owning your own chips allows you a significant economic advantage versus buying them.
There's a difference though in how you develop your chips, because these are patented
So I think
and
we're trying to intersect in the next generation of networks, and we're looking at this challenge in particular with defense and Golden Dome, that we want these satellites and these what we call payloads, the satellite sensors, to be resistant to jamming. Because if a jamming event occurs, it nullifies the value of your network. So we are looking to create more and more resistance or resilience to that kind of jamming event. And so that requires some deep thinking and actually design at the semiconductor level to do that. I mentioned economics before. So if you're building your first satellite network, the economics of doing that, you're not going to apply a lot of extra circuitry or energy into the jamming problem. It hasn't existed yet. So I think we're somewhat on a fair race now with others to develop this sort of jamming resilient capability. And as far as I know, we're the only non-SpaceX Amazon entity addressing it at the semiconductor level.
And how you were mentioning before that you build them from the ground up. Is that the right?
Yeah. So we're building
we're
building chips, and we're building chips, and then we decided we don't want to be a chip supplier to we wanted to build antenna systems. We view antennas as, in particular, antennas, we could call them apertures. They are our interface to electromagnetics, electromagnetic domain. So radios, even optical signals, all go through. They're all electromagnetic signals. And the new tech on the block there is what's called a phased array antenna. And it's a flat panel antenna that allows you to essentially focus your energy or focus your vision on spatial regions. So instead of tuning a dish, which is a mechanical steering antenna, we can do that electronically. And those phased array antennas are a array of hundreds to thousands of chips on a board. So when we looked at scaling up to antennas, it was an obvious value add for us to say, well, instead of selling one chip and trying to figure out how to create a business in the semiconductor only domain, we can position these in our custom antennas, and that would create a higher value for our company, as well as solve more of the problem. Okay. So we would be solving system problems at the chip level versus reacting to what system level guys told us about how to build the next chip with. So it's a way to kind of get ahead of the market a bit and solve things at the fundamentally the application level.
This seems to be a very competitive space. But I'm surprised there's not more players. Is it really
it's expensive?
Difficult? Yeah, expensive.
Yeah, and the market isn't wide open. There's not 1,000 customers or even 100 customers. So in the beginning, there was one customer. There was just SpaceX. And so they built their own internal team. Great. Amazon followed suit. The government with Golden Dome has sort of initiated, I think, the development of an ecosystem of companies now. We might be one of the first or ahead of that curve a little bit, but I foresee there will be more entry points into that market pretty soon.
Because they're putting like 175 billion, is that right, into
Hmm.
this project?
I'm glad you mentioned that number. It's not a small number. So I I think that number needs to be that's a stunning amount of money allocated for a particular defense interest, and it kind of shows you the value that the State Department, Defense Department of War put on defending our space-based assets. It is so recently there was a public release of SpaceX earning a $2 billion contract for updating their satellites for what could be Starshield, but essentially kind of Golden Dome related funding. And at $2 billion, it's a tremendous amount of money to update a satellite network. Well, it's enough, but it's a ton of money. And you think, well, I'm going to spend 175 billion. Now I can look around the room and I think, well, there's just SpaceX, Amazon, and both those companies don't need any extra money, but they'll take it. But
Right.
but there's basically an ask from the government to build a space ecosystem, perhaps with less dependency on a handful of billionaires.
How far away do you think we are from like a Star Wars type
Yeah,
situation in space?
it's pretty fast. It could happen faster than people anticipate.
That's what I was thinking too, because especially with AI.
Yeah. AI is one of those crazy things that when it hits you in the rearview mirror, you'll wonder like, what was that? So the nice thing about space is that you do have to launch, and systems are very difficult. China's had a lot of trouble putting up a space network. Um, there's a lot of technical challenges, and so while we have this technical lead, we are probably in a fairly safe vibe to it. That could change in the scope of a 12-month kind of period, but I think it's not as fast or as immediate as sort of the AI threat we're kind of already kind of focused on. So how far away is it? Handful of years. But absolutely, Russia, China, all our adversaries do not want us dominating the space ecosystem.
Is there ever a world where a semiconductor chip could go inside of a human?
Yeah. So bio augmented. That's we had Lee Majors in the 70s and 80s, running around as a bionic man. No, I think what happens is that you get better sensors.
Because I'm reading this book called The Singularity is Nearer.
Yeah.
Have you heard of that?
Yeah, well,
It's by Ray Kurzweil, I think.
okay.
But the premise of it is just basically saying like it's nearer with AI, and we're like, it's saying like I haven't read the whole entire book yet, but it's basically like saying humans are gonna merge with AI and maybe like form a new species or something. So I can't help but think like, does that have to do with like a semiconductor chip inside of us? Like,
there have been a couple interesting movies that I watched. One of them I think countering that a little bit was Ready Player One and a few others, and one of the ideas in there was that that we remain our biological organisms. We need food. We live in poverty, but we can immerse ourselves, put on a headset, and now we're in a virtual world. I think that is very real. So that is something. That electronic world exists. So there's VR goggles and space, and that's a defense world as well. So I think there's a world where we sort of are in an AI alternate reality, sort of speak, and then you think, well, is there a way to improve our physical prowess in the physical world? And that one's a little bit more further out, because the merging of electronics and biological, our brain, we don't really have that capability. It seems like that's pretty far away still.
I would think so too, but I am curious because it
Yeah.
is like there's
Yeah. Well, let's just get better medical equipment, better
yeah.
surgeries. We can live longer with
I
better.
think we're gonna live a lot
Yeah.
longer. I feel like
I'm not
there's
ready for the bionic eye just yet.
yeah.
But we could have a few extra sensors. I'd rather wear a sensor. Like give me a jacket, and then it
Yeah.
just improves my visual audio experience versus having
Wasn't
it
like
embedded.
didn't Eon like put a chip inside him at is that
Yeah, well,
I remember that.
Neuralink is trying to bridge into a human brain interaction. So I just don't think, as complex as the brain is, that we are close to merging it. And AI and artificial intelligence is a totally different thing than our human brain. I think we're just now trying to study the human brain as a complete processing system. So that's where AI will probably arrive at. But the merging of those two, I don't know. It doesn't seem like it makes a lot of sense.
I don't know, we'll have to see. Well, we only use like 10% of our brains anyway, right? So that's a kind of interesting too, is like, okay, where is this 90 dormant percent of our brain and why aren't we able to tap into it? And how mythical is that going
what
to
is a
feel?
human experience? What do we
what is
want
that
out
going to
of
look
life?
like, because there's a lot of tests being done right now on like people transmitting thoughts, and there's a lot of people who believe that's real, and then there's like scientific proof that it is too. So I'm just curious, like how all these things are going to play in together. And I can't help obviously continue to think about like Star Wars when we're talking about these topics and what's going to happen in space. And it's like, are those characters created from us merging with AI and semiconductors?
I can only, my small brain that I'm only using 5% of, can only kind of imagine the impact on the space model. And one of the global impacts I think is really, ambitious for the human race is this connectivity. And I would say connectivity, great, we can talk, we already have cell phones, but it's access to information, right? If you're a farmer and you just don't know, how do I, till my land? How do I build, a canopy to, what part of the season am I in? All these things you can follow what's tried and true, or you can search an information source that might have the world's best answer for what you're looking for. And I think that we take that for granted in the U.S., that it's just, information is right there. We can ask it silly questions. But access to that kind of global information, I think, and the connectivity to kind of move information, I think that changes. We haven't done that. I think we're still going to benefit quite a bit from that kind of global consciousness.
Yeah, it is interesting. I work with a hypnotherapist on a regular basis, and she was mentioning something the other day during our session, and she's like everything is already here for you, and it's a matter of, she was like, think of it like there's every music you can think of playing right now, and you just have to tune into the station that you want to hear. And I'm like, that's such an interesting way to think about our world and what we want and how we're like, could we just tune in? And what are we, because I'm thinking like, what is that 90% of our brain that is not, that have we not figured out tuning yet? Have we not,
Yeah, well, maybe the monks have, right?
I know, maybe, but I was like, that was an interesting.
Some people that can really zone out. As we learn more about AI and we kind of bridge into that world, it's going to teach us a lot about ourselves. It's not a venture that doesn't come back to us, right? We're creating it, and so I think we'll learn some things.
Are the semiconductor chips playing a big part in data centers?
So they are data centers. I mean, they're the world's largest companies. I don't know how much larger NVIDIA can get, but they make a general purpose data center chip. And so they just make the best one. And the best one in that market is one, because it's like, I want the best chip if I'm building my data center out. And so they, the semiconductors are at the core of that entire race, right? We've got TSMC in Taiwan, I said manufacturing. we've got NVIDIA's, we've got Broadcom's, we've got Huawei's in China. You've got these massive companies fighting for that AI data center race. Yeah.
What did China just came out with something about banning chips for them domestically?
Well, to China, Taiwan is technically part of China to China, and Taiwan views itself, I believe, as a free, democratic, isolated from
Oh yeah, they're
free
banning
China.
state-funded data center AI chips from state-funded data centers.
In China.
China bans
Well, I think they want
foreign
to
AI chips
they
from
want to take
state-funded.
away the NVIDIA access. That's correct. Now, it's not that much money to NVIDIA. It's probably, well, the numbers actually were a lot smaller than I expected. But the idea was that it's a huge market for NVIDIA to be selling their chips into Chinese data centers. But the more chips they put into Chinese data centers, the less Chinese chips have opportunities to win inside China. So China's basically saying, look, we want a domestic supply of our own AI.
Are they worried about data sharing and us having access to their data? Is that a possibility at all?
It's a little bit of it, but that's a comm network, and I think they can
Okay.
manage that. So I think what they're really saying is we don't want to fuel the West's race to win in AI. We don't want to be paying for them to make the best chips anymore. We want to fund our own local companies, Huawei's, and so on. And the challenge they have is that the manufacturing base that NVIDIA depends on is right in Taiwan. And so technically they could probably argue that they own Taiwan. They could just say stop making NVIDIA chips, but I think that would disrupt the whole world economy. But if you look at Huawei, I think Huawei cannot, it's a Chinese entity that makes chips comparable to NVIDIA, at least at some levels. And they are not allowed to make their chips in TSMC because of our government. So I think we have...
Because why would we want to sell to them?
Because money.
Okay.
It's NVIDIA shareholders would be happy with continuing to keep China flush with cash.
Because I'm seeing that senators are asking Trump to continue banning from selling chips.
Yeah.
It's chips in China. And China's saying we're banning. So aren't they saying the same thing?
Yeah.
Or am I not?
The angle
something?
is we sold Qualcomm sold cell phone chips to China during bans in China, and the reason was, well, if we don't sell those chips into China, China will make its own cell phone chip maker equivalent to Qualcomm, and then we won't have an advantage in cell phone chips. Now that's maybe, it benefits our local companies, our domestic companies that we sell into China, but I think there is an angle that, like, if we stay back, they will do it on their own. It's a very industrious country, right? They generate more engineers, they have more people. So there's quite a bit on their side in terms of if we made it a war of just who can build the best chips. So we're ahead and we have advantages in our education system and how we've developed our chip industries, but they are fastly, they're catching up and they will surpass us in those capabilities over time. There's almost no, that's an inevitability. So we more or less have to get to space. Let's go back to space.
Sorry.
We got to get to space first, and we got to kind of seal that domain a bit and keep us in the lead in space. That gives us this nice global network, freedom of information model. And I think in terms of AI, your bet's as good as mine. I don't know what happens with AI, but it is taking the world's attention right now. It's a lot of money and attention on something that may or may not be as impactful as predicted. It's very uncertain. We don't know.
Where does AI play into space?
So I'm kind of with, there's a company called Anduril we really like. It's a very aggressive, defense-oriented equipment platform company. They build drones, they build submarines. He had a nice quote. This is Palmer Luckey. He quoted, we use AI, but we use it within platforms. If it doesn't do something for us, we're not asking an intelligent question of we don't need a language model, to describe how this submarine operates. We just want it to operate autonomously. And so where AI is in space, it's autonomous navigation, it's autonomous reaction. So an AI processing capability in space for us, we have AI feature sets in our chips. We are sensing jammers and reacting to jammers as fast as we think we can using AI or intelligent decision making on chip.
Okay, so it's actually playing a really big role.
It is. It allows us some freedoms to train devices with different scenarios versus just having pre-programmed functionalities. This happens, that it does. You do this. This happens, you do that. So AI is a little more flexible, quite a bit more flexible on adaptability. So having some AI presence in your satellite will be. I think it's already there. But in our chips, we're doing it for anti-jamming capability. Yeah.
Yeah, this anti-jamming capability seems to be like incredibly important because when I think of like satellites coming over and from Russia,
let's jam those, right?
Yeah, that's
I don't want those doing
because they're not able to do that right now.
Right, they're not over our heads yet.
How come they're not over our heads yet?
They don't have the launch capability.
Okay. And so the launch capability is what's going to put this into a new competitive space. And that's what SpaceX and Blue Origin is doing.
Yeah, thankfully. Yeah.
And they have does one of them have more launch capability than the other?
Oh, SpaceX. It's I don't think Blue Origin has made a commercial launch yet. But yeah, SpaceX is extraordinarily far ahead, and with Starship, which is being built in Texas, it will be several orders of magnitude, maybe at least one order of magnitude more capable than other launch vehicles. And so I think the beauty of SpaceX is that there's a really tremendous organization that started and visualized this, maybe a decade ago. So it's an engineering run organization as well. It's kind of apolitical. It's kind of just done what its mission is. Famously, its mission is to go to Mars. But along the way, we're going to drop Starlink and cover the Earth with satellites and create a tremendous business model for their company.
I think that's the story most people are missing. Yeah. When I think of SpaceX, I also think of Mars.
Yeah.
When I think
Mars
of space,
is like, look over here, this red planet.
Yeah. Is that like a distraction so that we're not really paying attention to?
Yeah.
Okay.
It absolutely
that makes
is.
sense.
I don't think it's purposeful. It's a good mission because to become an interplanetary species is sort of if you're Musk and you have $500 billion of net worth, what is the human experience?
Right.
I think he's looking to kind of ask, what are we here for? Mm-hmm. And if it's not to explore, then, let's just, watch baseball. I don't know. I mean, it gets pretty mundane. I think the world is far more interesting if we are exploring, and we're exploring Mars, exploring the moon. We still have to explore the oceans, right? So exploring is kind of in our I think it's a Moana song. Yeah, it's kind of in our gene pool. So I think that's kind of what's exciting about space. Space has been exploration, and it's kind of new ground for our new kind of space-based networks and assets. Yeah.
Well, this is incredible. I feel like it's an honor to know you and to be a part of what you're doing and to be able to get this kind of information, because it is always about like the flashy headlines, and it's really incredible to meet the people behind the companies that are changing the world and will, protect us from space war.
Yeah. Well, we have a role. And I think when you look at it, I've always been an engineer, right? And so I think engineering is finding solutions. It's solving problems, and you just need problems. So we've got problems, and
and you're here to solve them.
We're gonna try and solve them one at a time.
That's exactly how I feel too. I'm here to solve your problems.
Yeah. So thank you for having me.
Yeah, this was amazing. Thank you so much. And it's Next Semiconductor Technologies. You guys are gonna have some massive announcements soon. So be sure to just keep an eye on them. Mike Kappes, you can find him on LinkedIn. And yeah, stay tuned. Thank you.
Thank you.